This recording will show you how to implement Rung-Kutta method by the CASIO FX991ES calculator. We'll start with the introduction, then followed by the example, and finally showing you how to implement Rung-Kutta method with CASIO FX991ES. What is a Rung-Kutta method? Given a differential equation, dy dx equal to f of xy, and the initial value when x equal to x0, y equal to y0. Now, if x1 equal to x0 plus h, what is the corresponding value of y? Say y1. Rung-Kutta method is a numerical method to solve the above differential equation. The procedure of Rung-Kutta method is described as follows. Given that dy dx is equal to a function of x and y, where x equal to x0, y equal to y0, and if x1 equal to x0 plus h, what is the value of y1? First, you find the value of k1, which is h times f of x0, y0. Then, you find k2, which is h times f of x0 plus h over 2, y0 plus k1 over 2. Then you find the value of k3, which is h times f of x0 plus h over 2, y0 plus k2 over 2. Then k4 is equal to h times f of x0 plus h, y0 plus k3. And y1 is equal to y0 plus 1 over 6 of k1 plus 2k2 plus 2k3 plus k4. So this is how Rung-Kutta methods work. Let's look at an example of solving a differential equation using a Rung-Kutta method. I have dy dx equal to x times 1 plus y, and y of 1 equal to 2. I want to find out what is y at 1.1 with the step size of h equal to 0.1. For this example, I have the function f of xy is equal to x times 1 plus y. And I also have y of 1 equal to 2. This means that the beginning value of x is 1, beginning value of y is 2. x0 is equal to 1, y0 is equal to 2. Now, x1 we have equal to 1.1. So we are looking for y1, the corresponding value of y. So if I take h equal to 1.1 minus x0, which is 0.1, I'm going to use h equal to 0.1 in my calculation. So I have f of xy is x times 1 plus y, and x0 equal to 1, y0 equal to 2. So let's calculate k1. k1 is equal to h times f of x0, y0, where h is 0.1, and f of x0 is 1, y0 is 2. So this is equal to 0.1 times x, which is 1, y is 2. So the x here is this x here, and the y is this y here. So after calculation, we find that k1 is 0.3. So after I find k1 is 0.3, I'm going to find k2. k2 is equal to h times f of x0 plus h over 2, y0 plus k1 over 2, which is equal to 0.1 f of x0 is 1, h is 0.1, and divided by 2, y0 is 2, K1 is 0.3 over 2. This is equal to 0.1 times f of 1.05 and then 2.15. So in this case, the x is 1.05, the y is 2.15. So applying the formula f, this will give me 0.1 times x, which is 1.05, times 1 plus y, which is 1 plus 2.15, and you do the calculation, and you find that this is equal to 0.33075. That is K2. So after I finish completing my K2, let's move on to find my K3. So K3 is equal to h times f of x naught plus h over 2, y naught plus K2 over 2, which is equal to 0.1 times f of 1 plus 0.1 over 2, 2 plus 0.33075 over 2. That means this is 0.1 times f of 1.05 and 2.165375. So putting this in the formula for a function, x is 1.05, y is 2.165375. Our formula f of xy was x times 1 plus y. So this is equal to 0.1 times x 1.05 times 1 plus y 2.165375. Now this is equal to 0.3324. Then we're going to find the K4. K4 is equal to h times f of x naught plus h, y naught plus K3, which is equal to 0.1 times f of 1 plus 0.1, y naught is 2, plus K3 is 0.3324. So that means this is equal to 0.1 f of 1.1 and 2.3324 for y. Substituting into the formula with x equal to 1.1 and y equal to 2.3324, where our function is f of xy was x times 1 plus y in our problem. This will give us 0.1 times 1.1 times 1 plus 2.3324. So press the calculator manually, then we find that this is equal to K4 0.3666. So after I calculate K1, K2, K3, K4, then I can find my Y1. Y1 is equal to Y naught plus 1 over 6 of K1 plus 2K2 plus 2K3 plus K4. Now Y naught is equal to 2, and you go back look for K1. K1 is 0.3, then 2 times K2, and K2 was 0.33075, then 2 times K3. K3 is 0.3324, and plus K4 0.3666. So adding up all this is equal to 2 plus 1 over 6 times 1.9929. n, which is equal to 2 plus 0.33215, or in 4 decimal place, this is equal to 2.3322. So this is the value of y when x equal to 1.1. That means when x equal to 1.1, the corresponding value of y is 2.3322, given by Rung-Kutta method. Now I'm going to show you how to implement Rung-Kutta method with CASIO FX991EX. First, I'm going to find out my K1. Now, K1 is equal to h times f of x0, y0, where x0 is equal to 1, y0 is equal to 2. So this is equal to 0.1 times f of 1, 2. Now let's use my calculator to implement this. I'm going to use a function of my calculator. So what I'm going to do is enter the formula for h of fxy. H is 0.1 times f of xy is x. So I'm going to type alpha x times, open a bracket, times 1 plus y. 1 plus alpha y. Then close the bracket. So this is h of fxy. Then I'm going to press a calculate button. So they ask me what is the value of x. X is equal to 1 now. Equal. What is the value of y? Y is equal to 2 now. Equal. And you find that k1 is 3 over 10. Now convert to decimal place. SD is 0.3. So that means k1 is 0.3. Then I'm going to find k2. Now k2 is h 0.1, f of x0 is 1, h is 0.1 over 2, y0 is 2 plus k1 over 2. So this is equal to 0.1 times f of 1.05 and 2 plus k1 over 2. So let's see what is this k2 equal to. I call my calculator again. I have a function there. So I press calculate, and this time what is the x? It's 1.05 equal. What's the y? Is 2 plus k1 over 2. K1 was the answer given earlier, so I can press answer for k1 divided by 2. This is the value of y, press equal. So this is the value of k2. Convert to decimal place. SD 0.33075. So k2 is 0.33075. Next, I want to find out my k3. K3 is equal to h times f of x0 is 1 plus h is 0.1, then divided by 2, y0 plus k2 over 2, where y0 is equal to 2. So this is equal to 0.1 times f of 1.05, 2 plus k2 over 2. So let's call my calculator again. I'm going to keep the same function again, and this time I just press calculate. As usual, what is the value of x? Is 1.05, so you can see type 1.05 equal. What's the value of y now? Is 2 plus k2. Now k2 was the answer I obtained earlier, so I press answer divided by 2, right? 2 plus k2 divided by 2, then equal, this is equal to 0.33236. So this is equal to 0.3324. And finally, K4 is equal to H 0.1, F of X naught is 1, H is 0.1, Y naught is 2, plus K3. So this is 0.1 times F of 1.1 and 2 plus K3 as my Y. So now I call up my calculator again. This time I'm going to press calculate again. Calculate. The value of X now is 1.1 equal. The value of Y is 2 plus K3. K3 was the answer I obtained earlier, so I press answer. And this is going to be my K4 equal, you get 0.36656 or 0.3666. So after you obtain this K1, K2, K3, and K4, you can find out Y1 now is equal to Y0, which is 2 plus 1 over 6 times K1 is 0.3, 2 times K2, 0.33075, plus 2 times K3, which is 0.3324, plus K4, which is 0.3666, and you're going to get the value of Y1 as 2.3322. This is how you use the CASIO FX991ES to implement the Rung-Kutta method.